Back to Edupedia world. In the previous lecture we saw introductory lectures on lens, and today we will see the further continuation about lens. Specifically, we will see certain rays which help us in construction of image, which are known as principal rays of construction. And these rays are stagnant, rather, let's say this rays remains similar under different scenarios, so they help us in the construction of image for different cases. And secondly, we will see the concept about a real and virtual image. What is a real image and what is a virtual image. So we would like to see the position of the image formed and what is the nature of the image formed when a ray of light is refracted via a lens. In order to do this particular task, we will see three rays or three paths via which a ray always moves in a standard path, and those three rays will help us determine the nature of the image in different scenarios. So before beginning to see the special cases of different locations of object resulting in image, let us see the special ray of lights which is constant no matter what scenario we are discussing. There will be three rays of light, three for the convex lens and three for the concave lens. Let us begin with convex lens. So the convex lens is something like this, right? And we know that the principal axis would pass through the optical centers. Okay, now the nature of the ray of light that we are talking about is that if a ray of light passes through the optical center, then the ray of light will pass through undeviated. That is to say that if the ray of light is passing straight through the optical center, it will pass through undeviated. This is a straight line. Okay, now this is the case in any scenario. If it passes through optical center, it will go straight through. Now the second scenario let us discuss is we have the convex lens. This is the principal axis, and let the ray of light be arriving parallel to the principal axis. So something like this. This is parallel to this. So if the ray of light is arriving parallel to the principal axis, what will happen is that after refraction, the ray of light will basically pass through the focus. This is the focal point. So a ray of light coming parallel passes through the focal point. And the third scenario, the third case which remains constant is again a convex lens. The principal axis passing through the optical center. In this case, what we are doing is that the ray of light is passing through the focus here. Like before striking the convex lens, the ray of light is passing through the focus. This is our focus. Then what will happen is after refraction, the refracted ray of light will pass parallel to the principal axis. That this is going to make the principal axis at infinity. So to recap, this is when optical center, when ray of light is passing through optical center. This is when the ray of light is passing through when the ray of light is parallel to principal axis. this is when passes through focus. A point to note here is that this is f2, that is the second focal point, and this is f1, first focal point. Now let us jump into the discussion for the concave lens and similar parallel scenarios over there. Okay, so the concave lens will be something like this. Concave lens is like this, and the principal axis will be like this. This is the optical center, and in this case too, a ray of light which is basically coming straight and passing through the optical center, this is our optical center, will pass through undeviated, exactly like what happened in the convex case. This is the convex case, this is the concave case. The second scenario parallel to this scenario, let's draw it. This is my lens, this is my principal axis, and now if I draw a ray of light which is coming parallel to the principal axis, then since this is a diverging lens or a concave lens, the ray of light will move away. Okay, but if we extrapolate this backwards, then it will be something like this, and the point where it will strike, the extrapolated line will strike, will be the focus point. So similar to here the ray of light was actually passing through the focus. Here the ray of light does not pass through the focus, but if traced back, it would have passed through the focus. This is called f2 for the concave lens. Okay, so pretty similar scenarios here. Now the final scenario, let's draw the lens again. Principal axis, and in this case what we'll do is that we'll pass the ray of light through the focal point, but the ray of light through the focal point, we would mean that it should have passed through this focal point, not this focal point. So what will happen is, suppose the ray of light is coming like this, and if it continued to move in the straight line, then it would have struck the focal point here, which is the f1 point for the concave lens. Then the ray of light actually goes through this path after refraction, that is, it becomes parallel to the principal axis after refraction. Okay, so these are the cases which remains constant in all the scenarios, and in order to predict where the image will be, we need two rays of light. Any two rays of light meeting at a point will give our position of image and nature of image. So depending on different scenarios, we'll use any two of these three different cases for the convex or the concave case, right? So a very important take home from this is that we need to remember the three cases for concave and the convex scenario. Okay, we'll use this knowledge in our further lectures to discuss the nature of image under different given scenarios for both concave and convex case. Before we jump into that, let us see something what is known as the real image and the virtual image. Okay, So what is the difference between real and virtual image? We have what is called as a real image, and second is virtual image. Okay, now the properties of real image is that the rays of light after refraction actually meets at a point. So after refraction through the lens, the ray of light actually meets. In virtual image case, after refraction, a ray of light does not meet actually. Does not actually meet, rather it appears to be meeting at a point if it were extrapolated back. Okay, so the virtual image is such that if the rays of light were produced back, then they would have met at a point. So another point of difference is that the real image, if we bring a screen, the image actually forms on the screen over there, whereas for the virtual case the image does not actually form on the screen. So this is the basic overview of real and virtual image. Once we discuss about different cases of image formation, we will actually see what is happening when real and virtual image is formed. We will see practically what are those two cases. For the time being, remember this, that real image, the rays of light actually meet at a point. For virtual image, the rays of light appear to meet at a point. Okay, so with this brief introduction about the images and the basic principal rays of construction for a lens, let us in our next chapter see the cases of formation of image for a convex lens. So till our next lecture, have a great day. Goodbye.